All right, so today we are talking about lines, okay? Starting a new unit on functions. And so to rebuild your confidence, we're talking about lines. Yes, the basic lines, okay? And your goal today, you guys are going to be learning everything about lines for the third time in your math life, okay? So let's start it off. Suppose a theme park charges $10 entrance fee and $6 for each ride, okay? Long time ago, when you guys first learned anything about graphs, right? What did you used to do to graph anything?
A table.
You used to make a table, right? An XY table. Okay, you used to plug in values for X, and then you would get your corresponding Y, so you would get a point. Well, similar thing that you can do here. You can construct a table of values to show how the total cost in Y dollars is related to the number of rides. As you can see, when you've ridden nothing, it still is going to cost you money because you got to go into the park. Okay, after that, the amount of money that you spend ends up increasing. So when we plot these points, X, Y, on a Cartesian plane, does anybody know what Cartesian plane means? Raise your hand if you've never seen that word before. It's nothing but an XY plane. It's nothing but an XY plane. So when you see Cartesian, that just means XY plane. We see that they lie on a straight line. As you can see, here is 0, 10. So no rides, $10, and so on and so forth. And we say the relationship between the variables is linear. Continuing on with linear functions. Gradient of a line is the measure of steepness. And you see this formula, y2 minus y1 all over x2 minus x1. You've seen that formula before, right?
Yes.
Where have you seen it?
Slope.
Yes, and that's exactly what gradient means. Gradient means slope. So, IB uses gradient. So when you see that word, don't get confused. All that means is to find the slope. It still uses the variable m. M is still slope. That's also known as rise over run, or the change in your y's over the change in your x's. That symbol, that's the Greek letter delta. It means change. So as your y's are increasing or decreasing, as your x's are increasing and decreasing. Your y-intercept is the value of y when the line cuts the y-axis. Okay, so when you're looking at the graph, it's where the line crosses the y-axis. It can also be found when x equals what number?
0.
0. Very good. And the x-intercept is the value of x when the line cuts the x-axis, vice versa. So that means that is when
Y
equals 0. Very good. Moving forward, okay? Make sure I'm still recording. Good stuff. Here's an example. It says, what is the gradient of the last example, talking about the amusement park and the number of rides and the cost? What would be the gradient of this example? Anyone? It would be 6, because gradient, which means what again? Slope is talking about how your line is either increasing or decreasing as your x's are increasing and decreasing. You could have taken 2 sets of points on the table and did the slope formula, 16 minus 10 all over 1 minus 0. Yeah. So then that's going to be 6 over 1, which is nothing but 6. Okay? Or you can look and see, okay, how are they changing? How are they increasing? It almost kind of models an arithmetic sequence a little bit. Yeah? What about the y-intercept? Say again. 10. Now you want to be careful because the y-intercept is a point.
0, 10.
So then 0, 10 is your y-intercept. Okay? Our gradient is 6. And so what does this represent in context of the problem? Okay? You might have to explain or describe in words what do these numbers actually mean, which means you got to look at it in context of the problem. What was this problem talking about? Rides. Okay? More. What about the rides? How much it costs, right? It costs how much for each ride?
$6.
$6. How much did it cost to get into the park? $10. So your y-intercept basically represents when there's 0 rides, it costs $10. And that's like what you want to say, okay? To get into the park, it costs $10. Or when you ride 0 rides, it still costs $10. Okay? The slope, or the gradient, sorry. How would you represent that in context of the problem? The prices increase as the number of rides increase, okay? You want to make sure that you include both pieces, okay? Remember, gradient is the change of your y's or the change of your x's. So, the amount of money as it increases as the number of rides increase. Okay? Good stuff? Questions? All right. Now, if you notice, I leave some of these blank because I'm hoping that you guys remember this. Okay? If two lines are parallel, then they have the
Same slope.
what's another word for slope?
Gradient.
Yes, let's get in the habit of making sure that we use that IB terminology. Okay, so remember, parallel lines, they have the same gradient. So if one line is 3, the other one is also 3. Now, if two lines are perpendicular, then their gradients are blank blank of one another. Opposite. What's the other word? One word is opposite. What's another word? Yes. Someone said it. Yes. Opposite reciprocal. Maybe you learned it as negative reciprocal. Is that more familiar? Okay. So you want to use opposite or you want to use negative? Okay. First one I heard. All right. So negative reciprocal, which basically means that if one slope of a slope of one line is 3, then the slope of the line perpendicular, upside down T is the symbol for perpendicular, would be what? It would be negative 1/3. So you have to change the sign. So if it's positive, then the other slope is going to be negative, and then you have to actually flip. That's the reciprocal part. So negative 1/3. Okay? Do you remember that? All right. Now to prove that two lines are perpendicular. Now this is something that IB may ask. Okay? To prove that two lines are perpendicular, you don't say, well, it's opposite reciprocals of each other. Remember, because a prove or is like a show, which means you have to provide the mathematical reasoning behind it. Perpendicular lines, when you take their slopes and multiply them by each other, they should always equal negative 1. Every single time you have two lines that are perpendicular, their slope, the product of their slopes will equal negative 1. So that's what you'll need to do. You need to take the slope of one line, take the slope of its opposite reciprocal, and it should always equal negative 1 for you to show that lines are perpendicular. Talk about equations of lines. Okay? I'm handing you all lines today. Back when you first did lines, you used to do equations of lines one day, you used to do slow, perpendicular lines another day. Oh no, one day. Hand it off. Okay? Equations of lines. There are 3 different ways to write an equation of a line. Who remembers one way? Yes. Say again. Yes, y equals mx plus b. That was your algebra 1 way. IB does not use b. They use c. Okay? So y equals mx plus c. Okay? That was known as what? What form was that? Slope intercept. But we don't use slope in IB. We use. So this is your gradient intercept form. Doesn't sound as nice, but it is. The gradient intercept form where m represents the what? The gradient. And c, which you guys used to know as your b, is your what? A little louder. Your y-intercept. So y equals mx plus c. That was one way. Good stuff. 2 more. You had standard form. Okay? Standard form is also known as general form. That's not how you spell general. Yeah, standard form, also known as general form. Anybody remember what that was? Yes. Oh, we can't use C because we already used C for our gradient intercept form. So it's AX plus BY equals D, actually. Where A, B, and D all represent a number, a constant. Okay? A lot of times you'll see this notation. This goes back to your number sets. What does C mean? Integers. Okay? And a lot of times if it does actually write in standard form, then they need to be integer coefficients for your variables and also for your constant. Okay? One more way. One way. Yes, y minus y1 equals m x minus x1. What was that called? That's the right form. What was the name? What do you see in this form? Huh? You see the gradient, and you also have a what? An x1 and y1, which is called a what? What's x1 and y1 called when you put them together? There you go, point slope form. It's point slope. That's all you need to write an equation of a line. That's all you need. Point slope form. This one is the easiest way to write the equation of a line. Because all you need is a point. All you need is a slope to write point slope form. And sorry, let me rephrase that. Point gradient form. By the number of ways I'm going to mess up and keep using slope over gradient, you should never forget that gradient means what? Thank you. Okay? Where x1 and y1 are the points, and m is your gradient. And this is the easiest way to write an equation of a line. All you need is a point, all you need is a slope, boom, you're done. Okay? Y'all ready for some work, some examples? Okay. Now, let's look at this. It says find in gradient intercept form the equation of the line with gradient -3 that passes through the point 4, -5. So you're finding the gradient intercept form for the equation of a line that passes through the point 4, -5. So there are two different ways that you can do this. Okay? Didn't give you that much time. Just wanted to see if anybody was able to do this. You can do this one of two ways. The first way is using point gradient form. Because like I said before, in that particular form, all you need is a point and all you need is a slope. And you have both of those, don't you? Okay, so you can plug in -5 in for y. You can plug in your 3 for your gradient and 4 for your x. Okay? Two negatives make a what? A positive. So this is y plus 5 equals -3, the quantity x minus 4. And now they just ask you to write the equation of a line, and that's it. No form. That's your easy, in my opinion, that's your easiest way. But since it asks us specifically which form to put it in, we would need to take this from point slope or gradient intercept, point gradient form to gradient intercept form. Okay? How can I do that? What would I need to do in this case? Distribute the -3, so -3x plus 12, and then subtract 5. Because gradient intercept form is where it's y equals mx plus c. So you want it in the form of y equals mx plus c. And that's your equation in gradient intercept form. That's one way. The other way that you could have done it was going straight to gradient intercept form. Y equals mx plus c. Plug in -3 for your m, but then do what with your 4 and your -5? Some of y'all did it like on your desk, literally. Plug it in for x and y and solve for c. Okay? Because if 4, -5 is a point on the line, that means you should be able to plug them in for x and y at any point in your equation. So plug in 4 for x, -5 for y, and solve for c. So that's -5 equals, and then to solve for c, add 12. Be very careful. Some of these very simple algebra things could really mess you up and throw you off, like subtracting 12. Or, I don't know, saying that -5 plus 12 is 6 when it's really what? 7. And then heaven forbid you stop here and then you don't even write the equation at all. Have you written the equation yet? No, you just found C. That is a very common thing that I notice with students when they go straight to gradient intercept form. They'll forget to actually write what the actual equation is. They'll solve for C and then they'll stop. Okay? But either way, you still get your answer. Questions? Okay? Look at another one. I want you guys to write those two equations in their respective forms. Okay? General form. Remember, it's ax plus by equals d. Gradient intercept form is y equals mx plus c. So your goal is to get the first equation to look like what you see in the orange, and then make b look like the orange. Do that on your desk. So, to get a in the general form, what do I need to do to get a in the general form? Add 2/3 x to the other side. When I add 2/3 x to the other side, it's going to be 2/3 x plus y equals 2. Isn't that in the form of ax plus by equals d? Yes. Yes. Sit. Okay? Sit. That's general form. Okay? Now, to extend this a little bit, because it didn't specify whether to write it, make sure that a, b, and d are all integers, but a lot of times, IB will say, write the equation of the line in this form. And they'll actually say ax plus by plus d equals 0. They'll actually say that instead of saying in the general form. Ax plus by plus d is the general form. It's just when everything is all on one side and equal to 0. So, if I wanted to write that equation, that is now 2/3 x plus y equals 2, in this form that you see in the pink, I need to do two more things. What's one of those things? Subtract 2. I have to make sure that it's set equal to 0. So then that's 2/3 x plus y minus 2 equals 0. That's one of the things. I got to make sure everything is all on one side. Now, the second thing, because they'll say, now a, b, and d all need to be what? Integers. A, B, and D are not all integers. Mostly A. A is not an integer. It's a what? What's that called? A little louder. A little louder. It's a type of number set. Z means integer. This is not an integer. It's a what? A little louder. A little what? Rational. Yes, the rational number. Rational numbers are your fractions, your decimals that end, or your decimals that repeat. How do I turn a fraction into a whole number? Multiply the whole thing by 3. Very good. Whatever your denominator is in the problem for your A, B, and your D, if they're all the same, you multiply every single term by the denominator. If they're not all the same, then you multiply by the common denominator. Okay? So if you multiply everything by 3, 2/3 times 3 is what? 2. So that becomes 2x. 3 times y becomes, and -2 times 3 becomes, and now it is in general form, or in the form of ax plus by plus d equals 0, where a, b, and d are integers. Questions on that? Yes. Only in the orange, because I wanted to talk about the pink together. If it doesn't specify A, B, and D got to be integers, then you're fine. Move on. Okay? But I know IB. They're gonna ask that they be integers, and that's how you do it. Okay? That's all I'm make sure we did together. What about taking it from general form to gradient intercept form? Say again?
Solve for y.
Solve for y. I have to get y by itself because it's y equals, correct? How do I get y by itself? Subtract 3x. And then? And I divide the whole thing, everything by -4. Okay? Don't be cheap and just put one line and put -4 and say you've done it over. Don't do that. Okay? You make me chuckle, but don't do that. Alright? What's -3 divided by -4? A positive 3/4. So you have a positive 3/4 x, then a minus 1/2. There you go. Questions? So, that first example, we went from point gradient form to, or I showed you how to go from point gradient form to gradient intercept. Showed you how to go from gradient intercept to general form. Okay? There is no way to go like directly to general form. Okay? Without doing like a little bit of math. Alright? So, on this particular example, to get it in general form, maybe go one of the other routes first, and then get it to general form. Okay? So I want you guys to do this one. Okay. What you guys get with the integers? I'll take anyway. Like the integer answer.
-2x plus 3y minus 1.
Equals 0?
Oh, no, or it could be equal. Yeah. Yes.
Like this?
Yes.
Okay. Or, it sounded like you were going to tell me -2x plus 3y equals 1?
Yes, sir.
Okay. You could have also wrote down 2x minus 3y plus 1 equals 0. Could I have that one? Or 2x minus 3y equals a -1. All these are the same. Okay? It just depends on what side of the 0 you decided to put the 0 on. Okay, that's one reason. And then, of course, if you said it equals 0, if you didn't say it equals 0. But I'm going to go ahead and use point gradient form. So that would have been y plus 1 equals 2/3 x plus 2. If you went this route to start, did you get this? Okay. Then distribute over. That would be 2/3 x plus a 4/3. Yes? Then I need to subtract 1. What's 4/3 minus 1? So this is 2/3 x plus 1/3. And on top of that, since I'm putting it in general form, I could also subtract the y over, could I not? At the same time, set equals 0. I'll fix the order in just a second. What number do I have to multiply by? 3. When I multiply everything by 3, that should give me something that is not on this board. Why not? Did we mess up on the sign? Did I mess up on the sign? Something's wrong. The y is negative. Ah, okay. Maybe that's what's throwing you off. Okay. Do I have something like this on? Yes, I do. Okay, great. Woo. Questions about anything I did, minus the boo-boo. Sure? Yes. You talking about these two forms right here? Because see, in this case, I decided to bring everything over to the right side, so then that caused me to subtract my y. Versus if you brought it over to the left side, you would subtract your x. And so that's why any of these would be acceptable because depending on what side you move it to the zero. It doesn't specify they got to be positive integers or negative ones. They just got to be integers. Great question. Hello. You guys do this one. So, find the gradient intercept form of the equation of the line which passes through A and B. In order to find the gradient intercept form, I probably need the what? Say again? Gradient. Definitely need the gradient. So, to find the gradient, maybe negative 1 minus 2 over 5 minus 3. Yeah? Let's give it the gradient.
Negative 3 over 2.
Negative 3 over 2. Okay? So now that I have my gradient, what point should I use? A. Does it matter?
No.
Sure doesn't. Same thing, no matter which way you go. Okay? Doesn't matter. You could use A or B. Okay? But since you guys said A, I'll use A. Do you want me to go straight to gradient intercept form, or you want me to go point slope to gradient?
Straight.
I heard straight through. So here we go. I'm going to plug 2 in for Y, negative 3 over 2 in for negative 3 over 2 in for M, and then 3 for X to find my C. So that's going to give me 2 equals negative 9 over 2 plus C. How do I solve for C?
Add 9 over 2.
And when I add a fraction to a whole number, I need a what? So 2 is the same thing as saying 4 over 2. So that gives me a total of positive.
Yes.
Okay. So then that's going to be Y equals negative 3 over 2X plus 13 over 2 for my answer. That's a 2. Good? How are we with lines? Okay. Here we go. How do you determine whether or not a point lies on a line? Plug it in for what? X and Y. And if it does indeed lie on the line, so if I plug in negative 2 for Y and then 2 for X, what should happen? They should equal each other. So this is negative 2 equals, so does 2 negative 2 lie on the line? No. They should equal if it does. Same thing here, right? Let's see, we have 3 times 3 minus 2 times negative 1. It should equal 11. It's almost like you're proving, right? Deductive proofs. Yes. 3 times 3? Negative 2 times 1? Negative 1? So, what's that? So, does it lie on the line?
Yes.
Sure does. Okay. Good stuff. What about, what about trying to determine something like this? It says find M given that negative 2, 3 lies on the line with the equation Y equals MX plus 7. Say again? Plug it in and solve for M. Yes, so that means I'm going to plug in 3 for Y, negative 2 for X. Now, when I plug negative 2 in, is that going to be M minus 2? It's going to be negative 2M. Okay, negative 2M plus 7. How do I solve? What's 3 minus 7? So negative 4 equals a negative 2M. Now what do I do? Divide by negative 2. What's negative 4 minus divided by negative 2?
2.
So M is equal to 2. You do a similar process with the next one. Doesn't matter what form it's in. You still just plug in and solve for your variable, yes? Do I need to do that one? Graphing. Just a reminder. These are the lines. So when it's in gradient intercept form, you have Y equals MX plus C. You plot your C and use M to graph the rest, right? Remember you, what was it? Don't you drop something and then, I don't know these sayings that your teachers taught you, but yeah. Plot your C, use M to graph. Okay? Slope, rise over run, so you're either going to go up and over to the right, or down and over to your right. If it is in standard form, you can convert it to slope intercept form. There's nothing wrong with doing that. The only issue becomes is when the y-intercept is not a whole number. Now you're trying to guesstimate where it should go. Okay? When it's given to you in standard form, find your x-intercept and your y-intercept, plot those, and then connect. Okay? Might be a little easier for you. Okay? Are we okay? Do I need to do an example? I feel like this would be a fraction right there. Blank. I think I meant to put something in there. Let's just review, just to be sure. Okay? If I wanted to graph this, y equals negative 3 over 4, x plus 2, where should I start? At positive 2, and then I should go 1, 2, 3, 1, 2, 3, 4. And then I repeat, down 3, right 4. Or, from the y-intercept, I could go and left 4, and then boom. How many points do I need to draw a line? Only 2. Okay, so really truly, I could have stopped after that first one, just connected them. Okay? What about this? What is my x-intercept? Actually, on your desk, find my x-intercept and y-intercept for B. What's your x-intercept? 6, 0? Yes? Okay, remember, we just plug in 0 for y and solve for x to find our x-intercept. So then that just gives me a 2x equals 12. What's my y-intercept? 0, negative 3. Plug in 0 for x and solve for y. So then once I have those, all I have to do is plot them. 6, 0. Oh, very wrong. 6, 0. And 0, negative 3. And then just connect them. Y'all remember this? Maybe? Are we okay? Perpendicular bisectors. These are other types of lines as well, okay? Perpendicular means it forms a 90-degree angle. Bisector means it cuts into 2 equal pieces. So the perpendicular bisector of a line, segment AB, the line is perpendicular to AB and goes through the midpoint. Special feature about perpendicular bisectors, when they actually cut, A and B, those 2 endpoints are equidistant from the perpendicular bisector. What does equidistant mean? Same distance, equal distance. So when you're doing this, the trick is that when you're writing the equation for the perpendicular bisector, you need 2 things, okay? Just like before, when you're writing the equation of any line, you need a point and you need a gradient, okay? Now, considering that the gradient of a perpendicular bisector, it needs to be perpendicular to AB, or whatever the segment is that they give you, okay? So you'll need to find the slope of AB, whatever those 2 points are, and then get the perpendicular slope of it. Then that's your slope. So point, since it's a bisector, that means it goes through the midpoint. So then the point that you're going to use is the midpoint of AB, okay? So then you'll have your point, you'll have your gradient to write the equation of your line. Does that make sense? Okay. But before we finish up, anybody remember the midpoint formula? Because I don't think it's in your reference book.
Is it like y2 minus y1 divided by 2?
Close. Plus. The average between the 2. So it's y2 or y1. Basically, you add the y's, divide by 2, and the same thing with your x's. Add your x's, divide by 2. So that's how you find the midpoint. But you'll need your midpoint, and you'll need the slope the perpendicular slope to whatever segment they give you to find the equation of the perpendicular bisector. All right?